So welcome back everyone to my channel of learning and educating others. So today we are going to discuss in the stream of internal combustion engines. So far in the internal combustion engines we have seen about the four-stroke engines, the introduction to the internal combustion engines, diesel cycle and Otto cycle have been discussed along with the working of a spark ignition engine and compression ignition engine in detail along with their cycles. So in this session, today's session, very short session, we are going to discuss about two-stroke engines. So what is a two-stroke engine? What is its importance? What are the applications? And what are the pros and cons of a two-stroke engine when compared with a four-stroke engine? So this is what we are going to discuss today. So here you can see the working of a two-stroke engine. We will discuss this in detail. Have you observed any major difference here? Yes, there are no valves. There are no valves. Reverse intake valve as well as exhaust valve in a four-stroke engine. But here there are no valves. So that entire camshaft mechanism and that belt drive, all these things are replaced or eliminated. Instead of valves, they have openings called ports on the cylinder side walls. Okay, there are openings. You can see the opening here. There will be three openings, one for intake of the fuel air mixture, and the second one is to exhaust, and the third one is to transport or transfer the fuel air mixture from the crankcase to the cylinder on the top of the piston. We will see that in detail. This is a cut section view of a two-stroke engine. And another important thing you can observe here is the crankcase is sealed, whereas in a four-stroke engine this is not sealed. There will be a sump to lubricate it. So these are the features of a two-stroke engine. All the four strokes, namely the intake, compression, expansion or power as well as the exhaust, all these four strokes are completed just by the two movements of the piston between the dead centers. That is, the piston will be moving from top dead center to bottom dead center and from bottom dead center to top dead center. That's all. Entire process of the four strokes will be finished. That means the two strokes are combined each. That is, intake and compression stroke is combined. Power and exhaust stroke are also combined together. So there will be one power stroke for every crankshaft revolution, whereas in four-stroke engine, one power stroke was obtained for every two revolution of crankshaft, 720 degrees. But here, for every 360-degree revolution, we will get one power stroke. So there are only two strokes, the power stroke and compression stroke. The other two, intake and exhaust, are combined with these two respectively. The outward motion of the piston, that is from top dead center to bottom dead center in the case of a vertical engine, will be utilized, that is outward motion, away from the, that is expansion, will be used to slightly pressurize the air fuel mixture that will be taken into the crankcase. The air fuel mixture will be directly taken to the crankcase instead of cylinder. We will see that in detail. So here you can see the different parts of a two-stroke engine. In the case of a petrol engine, there will be a spark plug. if it is a diesel engine, there will be fuel injector. Okay, cylinder head and the fins, cooling fins, the different ports you can see on the side walls: intake port, exhaust port, and transfer port. As I mentioned in the beginning, the valves are replaced by the openings on the side walls of the cylinder, namely ports: intake, exhaust, and transfer. Instead of two valves, there are three ports. And there is connecting rod, crankshaft, crankcase. Okay, so this is a simple construction, the cross-sectional view of the two-stroke engine. So let us see the working. So what is happening when the piston is moving up and down, when this vertical arrangement? So here the piston is moving towards the top dead center. Okay, so this is the intake port. When the piston is moving towards the top, what happens is this is uncovered. This intake port will be allowing, that is, the pressure here will be reduced. So as a result of that, automatically the fresh charge will be entering the crankcase. Then the further motion of the piston upwards will open this transfer port. Here you can see the transfer port. Okay, so this upward movement, so this is combined intake is happening here, as well as the compression of already trapped fuel air mixture or the charge in the compression chamber, that is the top side of the piston, will be compressed. And one more thing you can see here, there is a deflector on the top of the piston. It is not flat. The top side of the piston is not flat. There is a deflector is provided. So that is given in order to avoid. So here you can see this is the exhaust port. The fresh fuel air mixture will be entering from the crankcase to the compression space through the transfer port like this. If this deflector is not provided, what will happen? Directly this fresh fuel air mixture may escape out through the exhaust port. There are chances for slight amount of period of time, this transfer port as well as the exhaust port during the downward movement of the piston, both will be opened simultaneously. So there are chances this fresh fuel air mixture may escape out through the exhaust port. So in order to avoid that, this deflector is provided on the top of the piston. So that you can see only in the two-stroke engines. There is no such a deflector in the four-stroke engines. So when the piston is moving up, it will get compressed. So at the end of this compression stroke, this spark plug will initiate a spark. Ignition will happen. As a result of that, this charged fuel air mixture will burn, start combustion, and it will burn, and the temperature and pressure will further increase, and the piston will be moving downwards as a result of that heat. So that expansion process will slowly uncover this transfer port, at the same time the exhaust port. So power will be obtained when the piston is moving down. This, as we can see, this crankshaft will be rotating when the piston is moving down. So that is the power stroke. So at the same time, during the downward movement of the piston, this exhaust port will be opened, and combustion products will be going out through the exhaust port. At the time, there will be no intake happening here. So intake will be happening when the piston is moving upward. Okay, so this is the working of a two-stroke engine. So as we have discussed, during the latter part of the power stroke, when the piston is coming down from the top dead center to the bottom dead center, the piston uncovers first the exhaust port, then the transfer port. So there will be a slight amount of time during which both the transfer port as well as the exhaust port will be opened. So there are chances that the fresh charge may get expelled through the exhaust port. So that is a disadvantage, and in order to overcome that disadvantage, that deflector is provided. Now let us see what are the disadvantages of the two-stroke engine. So generally they are less efficient than their four-stroke counterparts because of that incomplete expulsion. So not all the combustion products will be expelled through the exhaust port because it will get a very short period of time of the movement of piston from top to bottom. Then, as I mentioned earlier, the expulsion of fresh air fuel mixture. Even though deflector is provided, there are chances that the fresh fuel air mixture may get expelled. Then, because of the incomplete expulsion of the burnt gases, they are number one polluters. Two-stroke engines are terrible polluters when compared to four-stroke engines. Now, coming to the advantages, since the two-stroke engines fires on every revolution of the crankshaft, that is one power stroke for every crankshaft revolution, 360-degree rotation of the crankshaft, a two-stroke engine is usually more powerful than a four-stroke engine of equivalent size. Please note that, of equivalent size. So they are relatively simple and inexpensive. We have seen very simple construction. There is no overhead camshaft or valves mechanism are required. Simply the openings on the side walls, that is port, intake, exhaust and transfer ports are sufficient. So the maintenance as well as construction are very simple, as well as the initial expense is also very less. So they have very high power to weight and power to volume ratios. That means for a given weight, when you have to compare a four-stroke and two-stroke engines, a two-stroke engine will be having a high power because of the same reason, one power stroke for every revolution of crankshaft, which make them suitable for applications requiring small size, especially motorcycles, lawn mowers, chainsaws. All these are using two-stroke engines. So in the coming class, we will discuss about valve timing diagram, which is another important topic in internal combustion engines. Till then, it is goodbye. So if you are not subscribed to my channel, please do it and share with your friends if they are in the mechanical engineering field, especially if they are interested in internal combustion engines and automobile field. So happy listening. Have a good day.